Hello friends, greetings of the day. Welcome to the online session of Business Economics. In this session, we are learning chapter number 3, that is Theory of Production and Cost, and in that unit number 1, Theory of Production. Until now, we have learned the meaning of production, types of utility, then production function, two types of production function, that is short run production function and long run production function. Now we are learning another concept that is known as isoquant. Friends, iso means equal and quant is quantity. Isoquant is equal quantity. Friends, before we learn isoquant, we need to remind the concept of indifference curve analysis. Friends, you know very well that in indifference curve analysis, whatever combination the consumer was selecting, it gave equal satisfaction to the consumer. So the curve of equal satisfaction is known as indifference curve, and another name of indifference curve is iso utility curve. So iso stands for equal, iso utility, that is same utility or equal utility. Here isoquant, that refers to equal quantity or equal production curve. So isoquant stands for equal production curve. Now how does this equal production curve work? Let us understand. Isoquant are similar to indifference curve analysis of the consumer behavior. As I said that under the consumer behavior we were learning indifference curve analysis, and in that consumer was indifferent because whatever combination he selected he got equal satisfaction. So same way the producer is going to get equal production, so the curve of equal production is known as isoquant. Isoquant is also known as equal production, iso production, or production indifference curve. These are other names, do remember them. Now meaning of isoquant, it can be understood through this table. See, the factor combinations are given, factor x and factor y, two factors are there. If we can see factor combination A, we have got factor x 1 unit and factor y 12 units. This particular combination A, suppose it is going to give you the production worth 100 units. We can change the production combination. If we can use factor combination B, it is going to give you 2 units of factor x and 8 units of factor y. This is second combination, but this second combination is also going to give you the same production, that is 100 only. Third combination, if we can select 3 units of x and 5 units of y, again it is going to give you the same production of 100 units. So all the factor combination, whatever be the factor combination, we get same production, that is equal production, and that is why it is known as equal production curve or isoquant. Now how does this happen? We can see that at combination A, factor x was 1 unit and factor y was 12 unit. We got 100 units of production. In combination B, we have increased factor x by 1 unit, but in order to increase factor x we have to sacrifice factor y. This rate of sacrificing is known as marginal rate of technical substitution, it is known as MRTS, that is marginal rate of technical substitution. So we are substituting factor x with factor y. We are sacrificing factor y in order to get one more unit of factor x. Now why do sacrifice? Because we have limited resources, and with that limited resources we have to purchase this factor x and factor y. So in order to purchase one more unit of factor x, we need to sacrifice factor y. So this sacrificing has taken place, and ultimately 1 unit of x has increased but 4 unit of y has decreased. So that does not create any effect on the production, and production will remain equal. Same way again, factor x has increased by 1 unit, but factor y has been decreased by 3 units. So it is also not going to give any effect on the production, and production will remain same. So these combinations, whatever combination we use, the production remains equal, and that is why this is known as equal production curve. This is equal production curve. We can see this curve IQ is isoquant. If we produce on this particular point, say for example this is point A, where factor y 12 units and factor x 1 unit, if it can give 100 units of production, point B will also give 100 units of production, point C will also give 100 units, point D will also give 100, and point E will also give you 100 units of production. So all the units give same level of production, that is why it is known as equal production curve. Now isoquants have all the properties similar to indifference curve analysis, but there is one difference. Whereas in indifference curve analysis it is not possible to quantify the level of satisfaction, but the level of production acquired by the producer is easily quantified. It means that the satisfaction cannot be quantified, but the production can be quantified. The higher isoquant shows higher level of production. So for example IQ1, IQ2, IQ3, these three levels are given. IQ1 suppose gives 100 units of production, so IQ2 will give 200, IQ3 will give 300 units of production. So while a curve on right side represents higher level of production, a curve on the left side will represent lower level of production. Next concept is iso cost or equal cost line. Iso cost, it represents the prices of factors. Factor prices are represented through iso cost line. It shows various combination of two factors which the firm can buy with given outlay. Firm has fixed amount of expenditure, and with this fixed amount of expenditure, how much quantity the firm can buy, this is represented through this iso cost line. Suppose firm has 1000 rupees and this 1000 rupees has to be spent on factor x and factor y. Factor x is available at 10 rupees and factor y is available at 20 rupees. Now if we spend entire amount, that is 1000 on factor x, how much of factor x can be purchased? If we can spend entire amount on x, 100 units of x will be available and 0 units of y. Or we can spend entire amount on factor y, we can purchase 50 units of y and 0 units of factor x. These two are the extreme situations of purchasing. A firm can use any combination between these. Now these are iso cost lines. So for example AB is iso cost, CD is second, and EF is another iso cost. Lower iso cost represents lower cost of production. Higher iso cost shows higher cost of production. So as we increase the line, it increases the cost of production. A producer will always try to produce on lower iso cost, because higher iso cost line represents the higher cost. Now let us find out the least cost combination. Least cost combination will be the combination where the firm incurs lowest cost in order to produce more output. The least cost combination of factors can be found out by superimposing isoquant on iso cost lines. We have to find out iso cost and isoquant line, and by superimposing isoquant curve on iso cost, we will find out the least cost combination. Suppose the firm has decided to produce 1000 units, that is represented by isoquant P. These units can be produced at any combination on line isoquant P, that is A, B, C, D up to E level. See this diagram. These all are the iso cost curve. L1, MM1 is another iso cost, NN1 is another ISO cost, and this is another ISO cost. On that we have imposed Isoquant curve. This is Isoquant curve, and at that particular point where Isoquant and ISO cost are tangent at point C, we can see this is point A. At point A the production will be 1000, but it is the highest cost. Point B, production will be 1000, but the cost is somewhat lower than that. But point C, the production is 1000, but the cost is lowest here. On point D again, production will be 1000, but the cost has increased. Point E, production will be 1000, but the cost has again increased. So out of all these points, the lowest cost is at point C, where Isoquant and ISO cost are tangent. At this particular point we can find out the least cost combination. So at point C, the firm will utilize OS unit of factor Y and OT units of factor X. The cost of producing 1000 units would be minimum at the factor combination represented by point C, that is tangent to MM1 Isoquant. At all the other combinations we can see A, B, D, E. These represent the higher cost, that is why they are not our least cost combinations. Thus factor combination represented by point C is optimum combination for the producer. Thank you for now.